All right, so let's have some fun with this formula. So it says, the drama club makes a big ball from foam to hang above the stage for a play. The plan is to cover the surface of the ball with metallic fabric. What is the minimum number of square meters of fabric that the club needs? When it talks about surface, right, and square meters, what we're talking about here is we're talking about surface area. So we don't really get much into surface area in geometry, right? I think you mentioned this back in middle school, right? But for spheres, they do like to use the surface area formula because they're pretty simple to work with, right? So here is your surface area formula for a sphere, 4 pi r squared, okay? So what we have to do here is we are given the volume, right? We need to find the radius from the volume, and then we need to plug that radius into the surface area formula to find the surface area. So we start with our volume formula, right? Volume is 4/3 pi r cubed. So that's going to be 1.8 equals 4/3 pi r cubed. Okay? So here's how I'm going to teach you how to do this. We're going to multiply both sides by 3/4 to get rid of the 4/3. So 3/4 of 1.8 is 1.35. It was a nice number. If you have to round, don't round. Now I'm going to divide by pi. So now I'll get a nasty number, right? So when I divide by pi, I'm going to take this on to Desmos. All right, so this is going to go away. I'll rewrite it on Desmos. So right now over here, I have 1.35 equals pi r cubed divided by pi. And when you take 1.35 divided by pi, you get that decimal. And again, I'll just put 0.4297 here. But again, don't round. And now, to get rid of this third power, you have to take what's called a cube root. Not a square root, a cube root. Cube roots get rid of cubes. So in Desmos, you have to enter that using the keyboard here. I don't know of a shortcut. So if I come here, so click on the next box. Here's my keyboard, right? Over in the functions, under, let's see, statistics. Wait, look at all these fun things. I'm looking. Oh, number theory. So this has changed, right? Wow. Right here it says nth root. We're going to click on that, and now we can type a 3 in for that index space, right? And now I'm going to copy and paste this. Copy and paste. And there is our radius. And again, I'm not going to round too much right now, so 0.7546, blah, blah, blah. Right? Leave it there. Okay, so that's your radius. So now you're going to use the surface area formula, not there, so I don't cover things up. So now the surface area is 4 pi r squared. So we're just going to put this number in for r and type away. So here we go. So 4 pi times, I'll put in parentheses, this number squared. And there I go, and I don't know what it said to round to, but this surface area is 7.15. So I don't know, if you put 7.1, this rounds up to 7.2. When I did it in my notes, I got 7.1. It's close enough. So 7.2 meters squared, sure. And that would be the surface area you need to cover this, or this would be the minimum square meters of fabric you need to cover up this ball. Okay, so going from volume to surface area, you also might go from surface area to volume as well. If you have to get the r by itself here, you would take the square roots if you're working with surface area first. Excellent. All right, next problem. Okay, it says, what is the volume of the hemisphere? Right, so it says a great circle is the intersection of a sphere and a plane containing the center of the sphere. So a great circle. So I took spherical geometry in college, a small little class, and we talked about great circles a lot. There's elliptical geometry, there's spherical geometry. We do plane geometry in our class, right? So nonetheless, a hemisphere's volume is half of the sphere's volume. So no big deal, right? So we're going to take 1/2 times 4/3 pi r cubed. This is your radius 4, so just plug it in. 1/2 times 4/3 pi times 4 cubed. All right? If it says leave it in terms of pi, you do. Otherwise, we're going to multiply it all out. And I would just type away that in Desmos. And I got 134 units cubed, not squared. I'm back on the last example. Units cubed, it's volume. 134. Okay, and last but not least, right, is our composite figures, right? So now as we have more 3D figures, spheres and hemispheres, we have more composite figures to talk about. So it says a solid is composed of a right cylinder and a hemisphere. So we have a right cylinder and a hemisphere. If the density of the solid is this, 100 kilograms per meters cubed, what is the mass of the solid? So density is actually a big deal application for the state test, because density is mass per volume, right? Density equals mass over volume. This is much more of a science topic, but they throw it in here because of the volume topic, right? So what we're going to do here is we have the density, and we're going to be able to find the volume. So if we have this formula, density equals mass per volume, if we multiply both sides by the volume, if we take the volume times the density, that's going to give us the mass. This is our end problem, right? So we have the density, we can find the volume, multiply them, and that gives us the mass. Okay, so let's break this problem into two parts. First is the cylinder. Okay, so for the cylinder, I have a volume formula of pi r squared h, area of the base times the height. This is your diameter, so your radius is 1. That's kind of a nice radius to work with. So my volume here is pi times 1 squared times 3. Notice we stop here at the bottom of the hemisphere. I'm going to leave this in terms of pi, so this is just 1 times 3, which is 3 pi. I will then type it all out when I need to later on. Okay, now let's do the hemisphere. So the hemisphere's volume is 1/2 times 4/3 pi r cubed. Again, this base is identical up here, so this also has a radius of 1. So we're going to do 1/2 times 4/3 pi times 1 cubed. And again, in an effort to keep this as exact as possible, this 1 kind of goes away because it's just 1 cubed. 1/2 of 4/3 is 2/3. This actually becomes 4/6, and you can divide by 2 to get 2/3. And that would just be 2/3 pi. So here is going to be your combined volume. So your volume is going to be 3 pi plus 2/3 pi. Right? So now go ahead and multiply this out in Desmos, right? And I get 11.52. Really shouldn't round more than that, but I know I'm going to multiply by 100. Right? So this is 11.52 meters cubed. That's my volume. So now we're going to take that 11.52 and multiply it by the 100. Again, because they are both in meters cubed and kilograms per meters cubed, your answer will be in kilograms. And that's 1,152 kilograms. And that would be your mass of this composite figure. All right, great. Thanks for watching. Good luck on the practice.